Hello, this is Justin again at the Tech Train, and here with the 6th tutorial in this series looking at how to program using Small Basic. And in today's video we're going to look at something called loops, except that programmers don't like to use words that other mere mortals would understand. So in order to throw people off a little bit, we call loops iteration. Iteration simply means repeating stuff in a loop. Now, last lesson, in the last video, you can see how we created here some square shapes using the turtle and using an awful lot of copying and pasting. If you haven't seen that video, then head back and have a little look at it now, so you have some idea of what we're using here and how we're creating these shapes. If I run this program, it's exactly the same program as I used in the last video. So you can see here how my turtle is creating two squares, and it's doing that by repeating effectively the same two lines over and over again. So all of this stuff at the top here is just setting up the program. If we look further down, this here is the square on the right hand side, and this is the square on the left hand side. Now each of these blocks of code is basically the same two lines of code repeated 2, 3, 4 times, which of course makes sense because a square is basically that. It's move forwards, turn right, move forwards, turn right, move forwards, turn right, move forward, and so on. So what we can do instead, rather than writing out or copying and pasting all of these lines of code over and over again, is do something a little bit cleverer. And that is to tell the computer, look, I'm going to give you a couple of lines of code, do those lines of code 4 times. That makes a lot more sense. Rather than us having to write out all the instructions, we can instead say to the computer, here, take these 2 lines, do them 4 times. That's a lot less code. And the real secret about programmers is that they are monumentally lazy and always try and write less code than they possibly can get away with. So if you've got to write out 8 lines of code to draw a square, well, let's try and do it in half that. Let's try and do it in 4 lines of code. Makes much more sense. So how do we create a loop? Well, first of all, there are 2 types of loop. And the first type of loop is where you know definitely how many times it's going to repeat. And in this case, we want these 2 lines of code here repeated 4 times. So we definitely know the number of times we're repeating this loop or iteration. So that kind of loop begins with the word for, F-O-R, rather than the number 4. So for seems an odd word to begin with, but let's bear with me. The next thing we need to have is some kind of way of counting the number of times something's done. Computers are thick. They really are. And if you ask them to count from 1 to 4, they'll forget where they got up to even before they've started. So we need to have something in which they can, if you like, write down the number they've got up to. And that's a variable. We looked at variables back in the 2nd video in this series. A variable is just simply a little labeled box somewhere in the computer's memory where we can store something. And we can call that whatever we like. In this case, I might as well call it sides, because this is the number of sides in our shape. So this is a little box inside the computer's memory now, which we've labeled sides, and that is going to contain a number. And it's going to start with the number 1 and count all the way to the number 4. So the computer will begin this loop by making a little box in its memory, labeling its sides and putting the number 1 in there. Then it'll do this loop, and when it's finished the loop, it'll change the value inside this variable sides to a 2. And then it'll do the loop again. And when it's done that, it'll change the value in sides to a 3, do the loop, and so forth until eventually the value inside sides is 4. And because we're only counting from 1 to 4, when the value in sides reaches 4, the loop will end, and the computer will then move on from this part of the code to the next part of the code. Except there's a problem. Because, whoops, quite apart from my scrolling, which is a problem, but the problem is this. We say to the computer, we want these 2 lines of code here repeated, and here repeat them 4 times, but the computer doesn't know whether it's these 2 lines or whether it's those 2 lines and these 8 lines. It basically doesn't know where the loop is supposed to end. And so we have to end the for loop by writing end for. So now we've told the computer where the loop begins, we've told it how many times to repeat the loop, and we've told the computer when the loop is ended. So now, once the value in sides reaches 4, the loop will end and the computer will move on from this block of code to the next block of code. Now we can see how this works. If I run the program, you'll see that effectively what happens is absolutely nothing. As far as we're concerned, it's exactly the same program drawing the exact same shape. So there's no difference there. And we can see how these 4 lines of code here produce the square on the right, and these 8 lines of code produce the square on the left. No problem at all. So what I'd like you to do now, as I've asked you in several of these video tutorials in the series, is to pause the video in a second, and you're going to create a loop for these 8 lines of code here. Hopefully you've still got the program from last time. If not, then you'll have to create those 2 lines of code from scratch and put them in a loop. Now, one thing to point out is that this variable sides here, we have finished with that variable once we get to the end of the loop. So we can use that variable sides again and count from 1 to 4. So we don't need a different name there. If, however, we wanted to keep that number 4 in the variable for later, then possibly we might want to create a second variable. So shape sides 2 or something like that. But in this case, we're okay to use that variable again because we finish with it by the time we get to the end of this loop. So there's your little challenge. Try and create a for loop for this shape here on the left, and when you unpause the video in a second, I will show you the answer and you can check to see if you're right. So pause the video now. And now we carry on. So either you paused the video and had a go at it, in which case I hope that worked out well for you, or you didn't pause the video because you're a complete rebel and literally can't be bothered. But hopefully you'll still be able to learn anyway. So I'm going to remove those 6 lines of code first of all, and then surround these 2 lines of code with my for sides equals 1 to 4. And then at the end of that, I'm still going to have to use my end for in order to close the loop. So there we are. We've now got 4 lines of code where we had 8. And if we run the program, you can see we get the exact same shape. So a loop on the right and a loop on the left, or a square rather. And there we are. So the exact same shape produced using these 4 lines instead. So that's in essence how to create a simple loop, but there's a little bit more that we can do with this loop. And in fact, now that we've got a loop, it gives us a lot more control. And quite apart from reducing the length of our code, loops or iteration also provide us with another real advantage. I've just tweaked the code slightly so that I've now only got this one loop here. It's the same as the first loop, which creates the square on the right hand side, but I've removed the code for the square on the left. So what's this other advantage then? Well, the advantage of having a loop is that I can now make just 2 very small changes and end up creating an entirely different shape. For example, this at the moment draws a square, which has, of course, 4 sides, and I'm counting from 1 to 4. So if I wanted to draw, say, a hexagon, which has 6 sides, I can simply change that number 6. Now, of course, the other thing I'll need to do is change the angle, because a hexagon clearly doesn't have 90-degree angles in it. That would still produce a square. So I need to work out what the angle here would be. Now, possibly you might know what the angle is, but chances are you're not going to, especially if we start working with 11-sided shapes or 8-sided shapes. So how do we do that? Well, effectively, all we can do is think about how we would work out what the angle of a shape, of the internal angle, would be normally. How would we work that out? Well, of course, there are 360 degrees in a complete circle. And a square is just basically a circle with 4 sharp edges to it. So you're still going round in a complete circle. So 360 for a square, divide that by 4 angles, and you've ended up with 90 degrees. 4 90s are 360. A hexagon is, again, just simply another circle, except it's got 6 elbows rather than 4. So with a hexagon, you'd still have to work out 360 divided by however many angles or elbows it's got, in this case 6. So we can type in here 360 divided by 6. Don't forget that in coding we use the / to mean divide. We looked at arithmetic operations, that's the maths, in the tutorial 4 video. So if you want to have a look at that, just check back video 4 on the arithmetic. But this now says work out what 360 degrees divided by 6 is and take the result of that calculation and turn that many degrees. So now with those 2 small changes, the number of sides or the number of times we're repeating these 2 lines of code and the angle here, we can now produce ourselves a hexagon. There we go. And we can do the same thing by now changing these 2 6s to, say, 5s to produce a pentagon. And so on. We can now produce any regular-sided shape that we would like to. So that's another advantage of using a loop. We can now, with very small changes, make very dramatic changes to the end result. If we didn't use loops, we'd have to make several changes all the way through our code. And of course, when you've got to make lots of changes through lots of code, that's where you start to have problems. You forget a line, you overlook a line, you mistype something, you forget to change one of the numbers, and then your code doesn't work, and you've got ages of time now having to spend going through your code line by line looking for the problem. So repetition, loops, iteration, call it what you will, that makes a big difference to the efficiency of your coding and the ease with which you can edit that code later on. Now, there's something else that we can do here, because having a loop produces a single shape. That's fantastic. But what about if we wanted to produce lots of shapes? So here again is my hexagon, and I can see how I'm producing that hexagon. It's very nice, lovely. Oops, no, I didn't show. Oops, you see, I made a mistake there. 1 to 6 on the sides. I forgot to change the 6 on the angle. That's why it was still producing a pentagon. As I was saying, we can produce a single hexagon here, but what about if once we finished drawing the hexagon, we got the turtle to turn just very slightly, not much, and then do it again? Draw another hexagon out, and then when it finished that, turn slightly more and do it again, and then again, and then again. Now, of course, what we could do is write out loads and loads of this code, so we could copy this whole loop here and keep copying it out and pasting it, so we're doing over and over again, and each time after we finished it we turn a little bit. but that should hopefully remind you of the problem we had before. When you're starting to copy and paste and repeat a lot of code, it makes sense to start to think, well, surely we can put that in a loop as well. So what we're going to do now is put this loop inside another loop. So here, what I'm going to do is say for, now I'll have to use a different variable here because otherwise we're going to get very confused. So I'm going to call this shapes. So for shapes, oh, actually, no, I'm not, because you see how that's popped up as green? Not shapes, there we are. Shapes. It's popped up as green because that's actually a word that Small Basic recognizes, and we'll actually look at shapes in, I think, tutorial 11. So I'm going to call that something different. I'm going to call it pattern instead. So for pattern equals 1 to 36. I'm going to have 36 of these hexagons drawn. So now we've started the loop. It's going to draw a hexagon and it's going to end up repeating this loop 36 times. But after each of those loops, we want to be able to turn just a little bit. So I'll do turtle.turn, and here I'm going to turn just 10 degrees. And then I'm going to end the loop that I started up here on line 9. So what we have is a loop here which produces a single hexagon, a line that says once we've drawn the hexagon turn 10 degrees, and all of that is enclosed inside this other loop that says do all of that 36 times. Now what you might have noticed is that we're repeating this pattern 36 times, and each time we do we're turning 10 degrees. 36 times 10, 360. So that means that what we produce is going to be a complete circle of shapes. I'm going to start running the program, but it's going to take a little bit of time, so I will speed this up. But we can see how it produces the first shape, then it turns 10 degrees and starts producing the second shape. Then it turns 10 degrees and draws the third one, and so forth. So every time it draws a shape, it then turns 10 degrees and draws another one. And if I just close that for a minute and I change the turtle speed from 8 to 10, 10 is the maximum, and now I run it, you'll see that pattern producing much more quickly. There we are, that is one very speedy turtle. And so you can see by putting one loop inside another, with just a few lines of code, we can produce a lovely pattern. There we are. So we have a complete pattern of hexagons. Now, of course, by making some changes, perhaps by changing the shape that we're creating, let's say that we're going to create a triangle instead of a hexagon or something. So we can try running that. And with just a small change, we can produce a completely different pattern. So what I'd like you to do is, again, to pause the video, have a little look at this pattern, play around with making some changes and see what sort of differences you can make, and then come back to the video where I will then carry on looking at some other ways in which we can use loops. So have a little play with this. This is not the end of the video. I will just simply let you go away, have a little play with this idea, and then come back in a moment, unpause the video when you're ready. So if you want to pause the video now. And now I'm assuming you've had a little play with that and hope you've enjoyed that and had some fun. If you combine this with the colours that I was showing you earlier on, you can really produce some great patterns. So there's a lot that we can do with this, a lot more that we can do with this, and possibly I might come back in another video and show you that. But what I really wanted to do was to think about loops. And loops, of course, with graphics, with a turtle, we can see how that produces beautiful patterns. But what about with text? Because we did start off looking at text, to the text window in those early tutorials. The first 4 videos were all focusing on the text window. So what can we do with that? Let's think about things that we would normally repeat a lot that are based on text or words. And of course, one of the most obvious things, one of the things we learn when we're very young, are times tables. So let's write a program now that will do our times table for us. And in this, we're going to combine variables, string concatenation, and loops. So all of that combined now to produce a times table. Let's see if we can do this one. First of all, I'm going to create a variable. I'm going to call it num, and this is going to equal whatever times table I want. It's like the 3 times table or the 7 times table, or whatever it might be. Let's go for the 8 times table, shall we? So we'll say that num is going to equal 8. And now I'm going to set up a loop, and again, this is what we call a definite loop. We know definitely how many times this loop's going to repeat. I'm going to call this I, which is a letter that we often use when we're creating loops. I, of course, for iteration. So we tend to use I as our default single letter, but you can call it whatever you like. So for I equals 1 to 12, because that's normally what we tend to go up to when we're doing times tables in school. So for I equals 1 to 12, that's going to be a number which will count from 1 to 12, whereas num is a variable which will always stay as the number 8. So that's really all we need to begin with. The next part will be to output some text to the text window. So there's our object, text window, dot, and now we need the method, which is an action or a verb, and this is going to be write line. We're going to get it to write a line on the screen, and we need to open brackets so that we can start putting in this text. Now, if we think about the way we're going to write it, and I'm just going to break down here and put down what I want to see. So I would like to see something like 1 times 8 is 8. That's the kind of text that I want to produce. So in here, I have got to somehow produce that by combining the word times and the word is and replacing these numbers with either I or num, my variables. So first of all, the 1. What variable is this going to be? Is this going to be num or I? Have a think about it. Okay, it's going to be I, and because that's going to count. I is the one that's counting from 1 to 12. So this first number here is counting. 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24, and so on. So I is my counter variable, so that's the one that's going to start. After that, I need the word times. So I'm going to concatenate or join. We did concatenation in tutorial 3 if you want to go back and have a look at that one. But concatenation simply means to join together words or strings or variables. So the next thing is going to be a string. So it's going to be the word times. And notice how I put a space before and after it, because of course we'll want spaces between each of these words or numbers, and those are only going to appear if we put them inside our speech marks. So I times. Right, now we've got this number here. So again, have a think. Which variable am I going to have to concatenate here after the plus? And if you said num, then you would be correct, because this is always going to be 8. 1 times 8 is 8. 2 times 8 is 16, 3 times 8 is 24, and so on. So that is always going to be 8 in this case, so it's always going to be the variable num. You might wonder why I've not just simply written the number 8 here, but of course by having the number 8 assigned to a variable, it means that later on if I want to change it to the 6 times table, I can just change that number there and it will automatically update whenever we run this line. So far I've got this bit here, 1 times 8, I times num. Now I need to add to that, to concatenate this word is. So let's do a plus, and in speech marks the word is. Again, don't forget those spaces before and after the word is. So now we've got all of that. The final bit is this. Now, of course, this isn't going to be either the num variable or I, because this is going to change. It's going to be 8, then it's going to be 16, then 24, then 32. So this actually needs to be the result of a calculation. So after all of this, we need to have some sort of calculation where we're working out what I times num is. And we can put this in brackets and literally say I times num. That's what it is after all. The result of all of this is simply I times num. So we can put that in brackets and say to the computer, okay, just work that out. And when you've worked that out, concatenate it or join it to the rest of this sentence. And that would be it. That would be everything. We've got all that now. So the only thing we have to remember is to close the bracket that we opened at the beginning here. Looks as though there's a closed bracket here, but of course that's closing this bracket. If you're not sure how many brackets to close at the end, start at the beginning and just think, you know, how many open brackets have I got? When I'm working out a long formula or a long line of code, sometimes what I do is I literally hold my hand out, and for every open bracket I come across, I put one finger up, so my thumb or first finger up, and for every closed bracket I come across, I put one finger down, which means at the end of the line, all my fingers should be down. And if I've still got one finger sticking up, then clearly I've made a mistake with my brackets. You'd be surprised how many times something as dumb and simple as that has helped me spot a flaw in my code. So there we are. We've closed the brackets twice now. There's only one thing left, and that is to end our loop. Remember, whenever you write a loop, it has to end. So you can't start a loop without telling the computer where you are ending it, even if there isn't any other code after it. So now we've got our program. Let's run this and see what happens. So there we are. 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24, and so forth. So remember, this first number here, excuse me, this is I, this is our loop counter that's going along here from 1 to 12, and then it stops. 8 is just simply the value of num, which we said at the beginning. And here is the result of the calculation. So 8, 16, 24, 32, all the way to 96. There we are. And of course, by assigning the value of 8 to a variable, if we want to change that to, say, the 7 times table, we can just change that number there, run our code, and there we are. We've now got the perfect 7 times table. So that's a really good way of using iteration, using a definite loop in order to do something like a times table. So what I suggest you do now is, again, pause this video and you're going to have a go at writing this code out from memory, from scratch. It's a really good thing to do, just a couple of lines of code. Don't get hung up on, oh, do I need a bracket here, do I need a bracket there, you know, what symbol do we use here? That's less important. That's a little bit like, do I need an apostrophe here? Do I need a semicolon there when you're writing English? Yes, that stuff is important, and without it, things might not mean what you think they mean. But it's not as important as getting the basic structure and content there. When a writer is writing a book, they don't get hung up on every spelling and semicolon and apostrophe. They just blast the words out, get that written down, and then go back to edit it afterwards. When you're coding, if you get hung up on whether you need an apostrophe here or double speech marks there, the problem is that you're losing sight of the big picture. You're losing sight of what the problem is really all about. What are you trying to do? And if you get down the code in a structure that makes it clear what you're trying to do, then you can go and have a look specifically, okay, what speech marks do I need here? How many brackets have I opened? How many brackets have I closed? And just do the finishing off. So don't get hung up on the symbols too much at the beginning. Give yourself full marks if your code doesn't work, but you got the structure right and you just forgot a bracket here or forgot the speech marks or a plus sign. There's a small details that you can probably sort out fairly easily. So have a little go at doing that. Pause the video and I'll be right here waiting when you have. Okay, so either you paused the video or you didn't. Again, if you didn't, well, I really hope that you are putting this into practice, because while someone's telling you and showing you, yes, of course it makes sense, it seems very easy, but when you turn the video off, when you turn away from it and you haven't got that code there and you haven't got someone talking to you, it does make a difference. Psychologically, you're on your own then for a moment and you have to think differently. It's a different way of using your brain. So if you're not trying these things out, you're not going to get as much out of these videos as if you were pausing them and actually having a go. Anyway, if you did, brilliant, wonderful. I hope it worked for you. If not, then hopefully you've worked out where you went wrong. So let's move on and look at something a little more complex now. This is our last video looking at definite loops. So this one, we're going to try and produce the 10 green bottles song. 10 green bottles hanging on the wall, 10 green bottles hanging on the wall. If one green bottle should accidentally fall, then there'd be 9 green bottles hanging on the wall. So here we can see again where we're repeating a lot of stuff, but crucially, we're no longer counting up from 1 to 12. We're counting down from 10 to 1. So that's going to be slightly different. So what we're going to do here is start with a loop for I equals, and this is going to be 10 to 1. Now that's going to throw the computer, because normally what the computer does is say, okay, is this number bigger than the number on the left? So if it is, it keeps going. If not, then it stops. And of course, in this case, this number is not bigger than this number, so it's not going to start our loop. It's just going to give up. So we have to add something to this called a step. Now you can use step for counting up or counting down. It basically means how many are you counting up. For example, if we wanted to count from 1 to 20 in twos, we could say for I equals 1 to 20, step 2. If you wanted to count in fives, we could say for I equals 1 to 20, step 5. In this case, we need step because we're counting down, so we're counting in steps of minus 1. So we're counting from 10 to 1 in steps of minus 1. So that's set up our loop. Now we basically just need a lot of concatenation and strings. So let's do this. We'll have text window dot write line, and of course the first part of this is 10 green bottles. Now 10, that's not going to be a word or a number, it's going to be our variable here, I, because I starts off as 10. So it's going to start off with I, 10 green bottles. So we need to concatenate the word green bottles. Don't forget your spaces. 10 green bottles hanging on the wall. There we are. And then we can close our brackets. Now the next line is exactly the same. 10 green bottles hanging on the wall, 10 green bottles hanging on the wall. So we can just copy and paste that line. Now the next line is slightly different. I'm going to copy the text window dot write line, just copy that bit. So 10 green bottles hanging on the wall, 10 green bottles hanging on the wall. And if one green bottle should accidentally fall, well, that's just simply text, because the one there is always going to be the same. And if one green bottle should accidentally... Oops. No, I don't want to update that just now, thank you. Should accidentally fall. So that's just simply a string, no concatenation needed. There'd be, now what do we need here? Because here we obviously are referring to I, but we need I to be one less than it currently is. I is going to be 10. For all these lines here, I is still going to be 10. I is going to remain as 10 until we close the loop and the loop starts again, and then it'll be 9. So here we've got 10 green bottles hanging on the wall, and if one green bottle should accidentally fall, there'd be, now we know it's going to be 9, but currently I is 10. So we somehow need to say it's going to be one less than whatever I is right now. So in brackets we can put I minus 1. I is currently 10, we take 1 away from it. That's going to mean that we're now putting in the word or the number 9. Now we're not actually taking 1 away from I, we're not reducing this loop by 1, we're not saying I is now equal to I minus 1, we're just simply saying use the value of whatever I is now but 1 less than it. and put that into there. Again, we put it into brackets because we want the computer to carry out that calculation first before trying to join it or concatenate it to our sentence. So there'd be, in this case, 9, and then we're going to concatenate green bottles hanging on the wall. There we are. It's going to reduce the font size slightly so that you can see this more clearly. If you want to know, remember how to increase and decrease the font size, there's nothing at the top you can do that with, but if you hold Control down on your keyboard and use the wheel on your mouse, wheeling forwards will increase the font size and wheeling backwards towards you will decrease it. So there we are. Hopefully you can still see that. I do record all my videos in 1080 HD, so hopefully you can see that fairly clearly. If not, then just check your settings to make sure you are looking at this in HD. So now we've got the whole of the verse, but what we'd like to do is have a blank line between each verse. So to do that, we're going to have text window dot write line, and then just open and close speech marks and then close our brackets. So it's writing a line but with nothing in it, and the open and close speech marks signifies nothing. Finally, let's end that loop. So end 4. And then if we run this program, there we go. I'll just move that across there. So if I scroll to the top, you can see there we are, 10 green bottles hanging on the wall, 10 green bottles hanging on the wall. And if one green bottle should accidentally fall, there'd be 9 green bottles hanging on the wall. That ends that loop. So now I goes down to 9. So now we have 9 green bottles hanging on the wall. And again, this 8 is because we're doing that little calculation of I minus 1. 8 green bottles hanging on the wall. That closes the loop the second time. And now I drops down to 8. And so on. And we can see how we go all the way to the end with 1 green bottle. Now, this does say 1 green bottles, plural. We can sort that. I'm not going to worry about that right now. We'll look at some what we call decisions or selection in tutorial 8. So we'll look at that a little later, but that's something we can ignore for the moment. So 1 green bottle hang on the wall, and if 1 green bottle should accidentally fall, there'd be I minus 1, which is now 0 green bottles hanging on the wall. And that, of course, is our 10th loop, 10th iteration, and so the program ends. So there's another example of using definite iteration, but this time counting backwards. So again, what I suggest you do is pause the video, have a go at doing that yourself. If you have any problems, just go back, have another look at the video. And I've just got one more thing in this video to cover, and that is something called indefinite iteration, when we don't always know how many times something needs to repeat. So I'll let you pause the video, and I'll be right here in a few seconds when you're ready. So whereas a definite loop is one that begins with 4 and is used when we know definitely how many times code will need to be repeated, an indefinite loop or indefinite iteration is where we don't know how many times we're going to have to repeat something. For example, asking for a password to be entered. Now, we don't know if the user is going to get it right the first time, the second time, or the 678th time. We're going to have to keep on repeating that they've got it wrong and they need to enter it again until they get it right. So we're going to write a little program now which will use indefinite iteration to repeat some code over and over until the user enters the correct password. So I'm going to begin by putting a text window dot write line instruction that simply says please enter the password. There we go. And we'll now make sure that the user can enter a password, and we'll store that password in a variable. We'll call it password. It makes sense. So password equals text window dot read. Oops, text window dot read. There we go. So now after this text is displayed, the user will type a password in, and that'll be stored in the variable password. So now what we need to do is set up a loop that's going to constantly tell the user the password is incorrect and prompt them to enter it again until the password is correct. Now, of course, it might be at this point the password is already correct, in which case this loop won't even run once, and that is quite possible. With an indefinite loop, with an indefinite iteration, it is perfectly possible that that block of code doesn't run at all. So we're going to write here while, which is the other keyword we use for loops. So for is what we've been using. While. Now, while something is the case, or while something is not the case, and in this case it's while the variable password does not equal, and that's the symbol we use for does not equal, the less than and greater than symbols. So while the variable password does not equal fluffy123. So if the variable password doesn't contain that string there, then what are we going to do? Well, we're going to first of all tell the user with a write line that password not recognized, please try again. And of course, now we've prompted them to try again, we need to again have the variable password changed to whatever the user writes in the text window. So password equals text window.read. So these two lines here will constantly be repeated while the variable password doesn't equal that. Now, just as with our for loop, we had to start the loop and end the loop, we also have to do that with this type of loop as well. So we started the loop with a while, we need to end it with an end while. There we go. And of course, once they have entered the correct password, we can then put a message up to tell them so. So password, text window dot write line, welcome. So it's not the most secure of programs, I'll be honest, but we can see how this works. So this is our indefinite iteration, a loop that will repeat constantly while this condition is true. So while password is not equal to fluffy123. Remember that the password here is a variable that is going to contain whatever the user writes into the text window. So if I run this program, please enter the password. So if I type in the wrong password, there, password not recognized, please try again. Help, password not recognized, please try again. Password, no, not recognized, please try again. Fluffy123, welcome. So you can see there that in this particular case, we repeated that loop 3 times. And then eventually came to an end when I typed in the right password. If I was to run this program and type the correct password in first time, you'll see that that loop doesn't run at all. So this code inside the loop that said password not recognized and then prompted me a second time to enter the password, that didn't happen because the variable password did equal fluffy123. And we can see that in this loop here, that the loop only works while password is not equal to fluffy123. So that's an example then of indefinite iteration. And once again, what I suggest you do is pause the video, have a little go at doing that program yourself. You don't have to use my ultra secure password here. You can come up with whatever you want. But that's just a little demonstration of indefinite iteration. So I'll let you pause the video there. And in the next tutorial video, we're going to be looking at something called subroutines. And this is quite a powerful thing that we can use. So subroutines in the next tutorial. Do make sure that you're practicing all this stuff before you move on to the next video, as videos tend to assume that you've understood and become confident with everything that I've done in previous videos. If you haven't looked at previous videos and this has been a bit confusing for you, then feel free to head back to the beginning of this playlist and work your way through so that you feel confident with each stitch before you move on to the next one. Okay, thank you very much indeed. I'll see you in the next tutorial.